Alright, we're going to use this time to review how to calculate average atomic mass, or the mass that we see on the periodic table. And it's based off of the abundance of each isotope of your element. So one element might have 14 neutrons and 14 protons. Another element might have 14 protons and 16 neutrons. Another element might have 14 protons and 17 neutrons. So if the protons are the same, but the neutrons are different, you have an isotope. These different masses occur in our environment in different amounts. So we have to calculate the average as a weighted average, not as an average mean. So if we look at this graph, the y-axis says abundance, and the x-axis says mass. And so if we're going to calculate the relative abundance, we need to use the abundance values. So the first thing we're going to do is we're going to add up 110 from here, plus 65, plus 30. When we do that, we get 205. And so after that, we're going to make as many fractions as we have points. So if I have 3 points, I need 3 fractions. If I had 2 points, it would only be 2 fractions. And all we're doing is we're taking the part and putting it over the whole. So 110 is my part. My total is 205. On my next part, we have this value of 65. We're going to divide it by the total, 205. And so then the third one, we have this abundance value of 30. And again, we'll divide that by 205. And so we can use this either as a fraction or a decimal. However you want to plug it into the calculator is completely up to you. And so after calculating our relative abundance, now we actually get into calculating the average atomic mass. So there's a little bit of pre-work. It's a 3-step deal. And so when we go to calculate this average atomic mass, we're going to multiply our relative abundance value by the mass that goes with it. So when I have 110 divided by 205, my abundance value there is 110. So the mass that goes with it is 58. So we'll do times 58. We have 2 more abundance values and 2 more mass values that we got to worry about. So we got to do it 2 more times. So we'll do the 65 out of 205 times the mass that goes with it, 59. And then the last one, we have the 30 divided by 205 times our last mass, which is 60. And once we calculate these 3 values, we add them up. And so what we get, I used the decimal form on this slide. In the previous one, I used the fraction. So I have our decimals here. Same mass values that got multiplied next to them. And then this is what we get when we multiply it out. After we multiply everything out, we add the 3 numbers. So at the end of the day, we should only have 1 number. And what do you do with this number? Well, since it's a mass, an atomic mass, we look at the atomic mass on the periodic table. And whatever value your value is closest to corresponds to the element. So if we look at this one, 59.11 is close enough to nickel. And the reason it's not exact is just because of different rounding errors. There's ways to plug it directly into a calculator to avoid that, but given our situation at school, we can break it down and just deal with the rounding errors. So let's do this one more time. I'm going to let you pause the video and try to find the relative abundance. So we added up these three abundance values because they correspond to the numbers on the abundance, the y-axis. And then we found a total. So they divided the part by the total. And there's 3 points, so we got 3 values. Take another minute, pause the video, try to figure out what the average atomic mass is. So we take each one of these relative abundance values and multiply it by the mass. So 105 goes with 25. Or the first one that you calculated. If you go in order, you can think of it that way. The first one goes with the first one. The second one goes with the second one. You just have to be very strict on how you calculate that and the order that you do it in. So we have this 82 over 167, which is the same thing as 0.49, times 107, the next mass. We add up all of our final values, and we get 108.83. So the last step, we figure out what element has a mass close to 108.83. And if I look at this bottom number that's larger than the other number, larger than the atomic number, this mass number, which is protons and neutrons, the closest one is this silver atom right here. So this graph depicts the isotopes of silver. And that is all that I got for y'all. I hope this helps.